Today we're going to talk about an open source AI gateway called Bifrost. Now, the idea of an AI gateway, also called LLM Gateway, is that it serves as a middleman between us and multiple different model providers, multiple different interfaces that we can connect to, and it basically removes all the messy part of working with different providers, different interfaces, different rate limits, and so on. It unifies the whole process and makes everything easier for us. However, sometimes the AI gateway can become the bottleneck of your system because it's slow, and this is where Bifrost comes in. This is like the USP of Bifrost compared to something like Light LLM. It's blazingly fast and focused on scaling. So what we're going to do in this video today is we're going to take a look at it. We're going to set it up locally using Docker. As I said, it's open source, easy to set up. We're going to use it in order to work with different LLM models easily in Python and also in Claude code. And then I'm also going to show you how to integrate easily MCP tools using this gateway by using the MCP Gateway of Bifrost. If you like this video, let me know by hitting a like button and subscribing. But now let us get right into it. Alright, now let's maybe first cover what an AI gateway is in the first place. This is the one that we're going to talk about today, Bifrost. This is the GitHub repository, and this is the website. They say here the fastest LLM gateway, and here they also say 50 times faster than Light LLM. Now, the idea of a gateway here in terms of the LLM gateway and also the MCP gateway is that you have this central piece, this middleman, so to say, that you're routing all your requests through. So we have multiple providers that we want to be working with: OpenAI, Anthropic, Mistral, Ollama, and we don't want to deal with all the different interfaces manually. So we want to have one central endpoint that we're pinging, and then everything should be taken care of for us. This is the idea of an AI gateway. For MCP, we use the MCP gateway. For LLMs, we use the LLM gateway. And Bifrost is such a gateway optimized for speed and scalability. Now, it's also open source, as I mentioned. This is the code here, mostly written in Go, which is one of the reasons for why it's so fast. And we can easily set it up using NPX or also using Docker, which is what I'm going to do in this video today. Now, for the sake of transparency, I need to mention that Bifrost is sponsoring this video today. However, as I already said, it's all free and open source, so we don't have to pay anything in order to use it. You can easily set it up locally and use it for free. However, you might be asking, okay, why are they sponsoring the video then? What are they selling? They are mainly selling to enterprise customers. So if you like Bifrost because it's focused on scalability and speed, and you're actually building a large-scale AI application that needs a gateway, this is what they're basically selling you here. They have adaptive load balancing, which is optimizing the traffic distribution. They have a cluster mode, which allows the individual nodes to communicate with one another in a peer-to-peer way, in an intelligent way. And you have all the stuff that you need when you become larger, like audit logs and compliance stuff and governance stuff and logging and all this. This is what they're basically selling. So if you like Bifrost and if you're building a large AI company and you need an AI gateway, this is where they make their money. For what we're going to do today, we can do all of this for free with the open source version. And then maybe one last thing before we get into the practical part. As you can see here, it says 50 times faster than Light LLM. We could actually look at the benchmarks here. They have a blog post, a drop-in LLM proxy 50 times faster than Light LLM. And when we scroll down here, we can see that the success rate on the one hand is 100% compared to the 88% of Light LLM. And we can also see a massive difference here in throughput. And if you want to have an in a nutshell summary of that, you can see they add 20 microseconds of latency. So you have just 20 microseconds more latency by using Bifrost as a gateway. And you have a throughput of 5,000 requests per second. So this is really optimized for speed and scalability. But let us now move on to the practical part. For this, we're going to go back into the GitHub repository and we're going to scroll down to the quick start section. Again, here we have the npx command if you want to run this using Node, and we also have the Docker command if you want to run this locally as a container. I'm going to go with Docker, and in this video, I'm going to use tools like Docker, Ollama, and Claude Code, but I'm not going to go into the setup of those. I expect you to be able to set them up on your own if you want to use them as well. But what I'm going to do now is I'm going to navigate to my tutorial directory. This is where I want to be working at. And here I'm going to run the Docker command, which is this one, the second one, docker run -p 8080, and then the image identifier, so Maxim HQ Bifrost. However, I'm going to do two more things. On the one hand, I'm going to add an additional host because I want to be able to access the local host of my host system from the Docker container, because here I'm going to be running Ollama later on. So I'm going to do Ollama serve to host my open source language models locally on the system here. And I want to be able to communicate with this from the Docker container. So for this, I'm going to add a host. And the second thing is I also want to persist my config. So I'm going to create here a directory called data. And now I'm going to also specify that this is going to be a volume that is going to contain the configuration and the data from the container. So I'm going to close this. I'm going to say docker run -p 8080 8080. Now I'm going to add a host. So add host is equal to host.docker.internal. That is going to be mapped using a colon to host-gateway. And then I'm going to add the volume by saying -v, then $pwd to get the current directory /data, colon, and then we're going to map this to app/data, and finally maximhq/Bifrost. So this is my enhanced Docker command here. I can just run this. This is going to open up Bifrost running on all the different URLs here. So I can go to localhost, port 8080, and this is what the Bifrost dashboard looks like. Now, what we're going to do here is we're going to add, first of all, a couple of LLM providers to show you how we can easily use one central endpoint in Python. This is going to be the first example using it in Python, later on also in Claude Code, to show you how we can use these different providers using a single interface. So we're going to go here to model providers, configurations, and here now we have all the different providers. We can also add a custom one, and we're going to start, for example, with OpenAI. So what do we do here? We go to OpenAI, we say add new key, and this is going to expect an OpenAI API key. How do we get this? Open a new tab, go to the OpenAI API key on Google. This is going to take you to the platform.openai.com. You can log in, you can go to settings, you can create a new secret key. In my case now, I did this and I already copied it, so we can go back. So I just put in the API key here, I name it OpenAI key, and I save this. Hopefully all of this is censored if I don't forget it. And now we have OpenAI configured here. I can now do the same thing for Anthropic, for example. So I just have to go to platform.claude.com, then I can go to API keys, and then I can create a new one here as well. So I can say create key, and I can say default workspace, Bifrost tutorial key or something like this. Add, copy, go back to Bifrost, add new key, paste it here, call it Claude key, and save. And then finally, we can also go and do the same thing with, let's say, Ollama. This is why I wanted to add the host. Now here we need to provide the base URL. This is the thing that we want to connect to via Bifrost. And for this, you need to think, okay, what am I actually targeting? I'm targeting the local host of the host machine, so not of the container. And there I want to target port 11434, which is the Ollama port. So what we're going to type here is host docker internal. This is our host. This is mapped to our local host, and then the port. So HTTP host docker internal Ollama port, and that's basically it. Safe network configuration. And now, of course, I can go and run Ollama. However, in order to be able to access Ollama, we need to add an environment variable. So that's going to be Ollama host is equal to 0000 and then Ollama serve. That is going to make it accessible. I'm going to move this to my other screen. I'm also going to move this to my other screen. And now essentially we have Anthropic, OpenAI, and Ollama connected here, and we can use it via the Bifrost gateway. So let's see how this can easily be done in Python. For this, I'm going to navigate back to my tutorial directory, and I'm going to create a Python script. Let's call it main.py. In here, I'm going to use requests. So if you don't have requests installed on your system, you can either use a virtual environment, or on most systems, you can just do pip install and then requests. You can use UV, you can use a virtual environment, whatever. In my case, I have it as a system package. On Arch, you have to install it via your Arch package manager, but I think you know how to do that if you're using Arch. But once you have then requests on your system, what we're going to do is we're going to just send a simple LLM request to OpenAI, then to Ollama, then to Anthropic, and we're going to do all of this via Bifrost. So our target URL is not going to be the OpenAI API or something like that. We're going to target localhost on port 8080, which is Bifrost. And then to be precise, v1 chat completions is going to be the endpoint. Now we also need a payload. The payload is going to be our request, and our request will start by specifying the model. So the model that we want to use, let's say we want to start with OpenAI /GPT-4o, and then we want to say the messages that we want to pass here is going to be a list of messages, and these are going to be dictionary objects. Role is going to be user, and let's say the content is going to be what is Python, ? Answer in one concise sentence, just so we get the answer quickly. That is basically it. Now, in addition to that, I want to specify headers. The headers are only going to specify the content type here. So content type is going to be application/JSON. And then we're going to send this as a post request or using a post request to the endpoint. So request.post to the URL. The JSON object is going to be our payload. The headers are going to be our headers. That is going to return a response. And this response will have also a JSON object. And I already know where the output is going to be. It's going to be in choices, first element, message, and then content. So we can immediately print that. I can just say then Python main py, and that is now going to send a request to ChatGPT, to GPT-4o. Python is a high-level interpreted programming language. We can also, to make this more obvious, not ask what Python is, but we can say, who are you? What model? ? And then we can run this again. It should tell me that it's at least from OpenAI. I'm an AI language model created by OpenAI. Okay, it says GPT 3.5, but it is GPT-4o. And now we can easily swap that by just specifying a different model, and we don't have to change anything else about the code. So I can say here, I don't want to use OpenAI. I actually want to use Anthropic, and I want to use, to be precise, Claude Sonnet 4.5. Okay, seems like I don't have any credits with Anthropic, so that is a good opportunity to show you another integration. Let's go with Mistral. I'm going to add a new key here as well. Let's call this Mistral key, then save this. Now we have a Mistral key as well. You can see how easily this goes now, because instead of saying Anthropic, now I'm going to say Mistral, and I'm going to go with Mistral Medium 2508. So you can see, even if I just briefly plug it in, I can just run this now, and it tells me I'm Mistral AI, a cutting-edge large language model based on the Mistral 7B architecture. And you can do that flawlessly all the time. You can just go, plug in a new model, target the same endpoint a second afterwards, and it works immediately. Now let's see how Ollama works. You remember we just ran it, so I can go back into the Python file, and I can say Ollama / now on my system, I only have one model, so I'm going to use this one. It's Qwen3 with 0.6 billion parameters. So Qwen3 0.6 billion. And that should now also easily work. You can see here that this now received a request, and you can see I'm a language model developed to assist in conversations, and I'm trained on a specific data set. Okay, doesn't tell us much, but it actually used Ollama, and it used my Qwen model to give us that response. So this is how you can easily use the LLM Gateway. Now I'm also going to show you how to do all of this in Claude Code, but before that I want to show you how to work with the MCP Gateway. And for this we're going to do two things. I'm going to, on the one hand, add an existing MCP server that's publicly available, and I'm also going to briefly write my own MCP server and connect it to Bifrost. So for this we're going to go to MCP Gateway here in Bifrost, to MCP Catalog, and now we're going to create a new MCP server. We're going to start with the existing one. For this I want to use DeepWiki, which is a publicly available MCP server that doesn't need authentication, which is why I'm using it. And we just have to provide a name. We have to provide a connection type. HTTP is okay. And then I will just provide the URL, which is https and then mcpdeepwiki.com/mcp. So I can create this. This should then automatically recognize that this works, but I think I need to also say that there's no authentication, so authentication none. And by doing that, I mean, now I have two of these tools. Actually, I didn't need to specify none, but you can see that this is connected, and it also found three tools. We can scroll down here. We can see ask question, read wiki contents, and read wiki structure. And in addition to that now, I'm also going to code my own MCP server. I'm not going to type it here by hand now. I have it already prepared. I'm just going to paste the code here. So I'm going to create a directory here. Let's call it MCP server. Let's go into it. Let's say uv init, uv add, MCP, and also yfinance. This is going to be for getting stock information. And here now I'm going to call this server.py. I'm going to paste the code here. The basic idea is we have two MCP tools, very simple, with fast MCP. And the one tool is for getting prices for a given ticker symbol. The other one is getting news headlines or news titles for the given ticker symbol. The transport method here is streamable HTTP. That's essentially the whole magic behind it. I can now say uv run server.py. This is now running here on localhost on port 9999. And now I can go back into Bifrost, create a new MCP server, and refer again here to the Docker internal host, since we're now, again, still in the container communicating with the host system. So we're going to call this yfinance MCP or something like this. And we can then say http://host docker internal port 9999/MCP create. And then we have this already connected. You can see two tools are enabled. I can scroll down, news and price. These are the tools that we have access to. And now this is part of Bifrost as well. So we just have to target Bifrost, and it also handles the MCP tool use. So let me also move this now to my other screen. We have a bunch of stuff running in the background. And what we're going to do now is we're going to use Claude Code to connect on the one hand to our models, so to connect to Bifrost to use the LLM Gateway, but also to automatically recognize the tools from the MCP server and be able to use them. So for this, I'm going to open up a terminal. I'm going to navigate to my tutorial directory once again, and I'm going to create a directory some project. This is where I want to run Claude Code in. But before we run Claude Code itself, what I want to do is I want to set up some environment variables. So on the one hand, we need to change the URL of the API that is being used for the large language models. We need to change that to Bifrost. So I need to export here a key called Anthropic base URL, and we need to set this to HTTP localhost 8080. However, here now we need to target a specific endpoint, which is the Anthropic endpoint. So Anthropic is a specific endpoint from Bifrost for Claude Code. So this is how we export that. And then we should also overwrite the API key. So Anthropic API key is equal to dummy key, for example. Now, the last thing that we need to do before we actually run Claude Code is we need to make sure that we add the MCP servers. So for that, I'm going to say Claude MCP add -- transport HTTP Bifrost and then HTTP localhost 8080/MCP. This is going to recognize the MCP servers. As you can see, edit HTTP MCP server Bifrost, and now it has access to the tools basically. And now I can say Claude, just Claude basically in this project. I can say I trust this folder. Now you can see it's using Sonnet 4.5, but what I can do now is, first of all, I can go into the config and say I don't want to force the thinking mode because that would not allow me to use something like GPT-4o, for example. But I can then just say that what I want to do is I want to change the model to OpenAI/GPT-4o. And this is going to work via Bifrost. So I can say now, who are you? What is your model name? ? And I'm going to see that this is actually a GPT model. As you can see, it tells me it's Claude Code, but it's powered by GPT-4o. So let's see if it can use our MCP tools. I will say now, please look up the latest stock price for AAPL. This should now do a tool use for this MCP server of the Yahoo Finance MCP server that is still running here locally on my system. As you can see, it tries to use the Bifrost yfinance MCP price command. So I can say yes. What this is going to do now is it's going to send a request. It's going to get the number, and it tells me the latest stock price for Apple is $276. So now let's see if we can switch to something like Mistral. So Mistral/Mistral Large. That now is using another model. And now let's say, give me the deep wiki entry for React. So this should use now the tool for DeepWiki, and it should give me the Facebook React repo as a target. So I allow that, and this should now give me some summary of this. There you go. So the main idea is the following. We have one gateway for everything called Bifrost. We have all our MCP servers here. We have all our providers here. And the only thing that we need to ever target is this endpoint on localhost 8080. It gives us all the tools. It gives us all the providers. We can use even Hugging Face models here. So this is the all-in-one, high-speed, super scalable gateway for our AI applications. So that's it for this video today. I hope you enjoyed it and hope you learned something. If so, let me know by hitting a like button and leaving a comment in the comment section down below. Also, don't forget to check out the sponsor of this video today, Bifrost. The link is in the description down below. You would help out the channel, and I think it's a genuinely interesting tool to use. As I said, open source and free to use. So check out the link in the description down below. Besides that, don't forget to subscribe to this channel and hit the notification bell to not miss a single future video for free. Other than that, thank you for watching. See you in the next video, and bye.